All right, there we go. Okay, so compression dictionaries. And as you all have mentioned, this has been a while in the making, and a lot of it thanks to Yoav. I think he's been through every iteration of this as it's been in the making, including doing the original explainer for the new version of it. Yeah, feel a lot like Don Quixote chasing the windmills for all of the different versions of delta compression. Original version in Chrome SDCH sandwich was mostly used for dynamic resources, and it was in the critical fetch path. You created a dictionary, which was basically a VC diff. The server compressed a resource and said, hey, and this resource uses this dictionary, and the browser would, if it didn't have it, have to go out of band, fetch the dictionary. And there were, beyond deployment and code issues with it, there were challenges around privacy. And that's sort of what killed those first two iterations. And it actually worked out well. Generative AI does about as well with windmills as it does with fingers. And so those are AI-generated windmills, which is kind of how it feels like the original attempts for compression dictionaries went. The HTTP version we tried, HTTP2, we tried for cross stream shared dictionaries to, at the transport level, get some of the benefit of bundles of JS for a bunch of separate resources. Both of those ran into all sorts of privacy concerns when crime and breach and all of the side channel timing attacks became a thing. And so they were shelved for a while. In the last year or so, Yoav came up with an explainer that we're running with now that we think fits the web model much better and doesn't have the security baggage that comes with it. And so at its most fundamental, there's sort of two mental models you can think of for the shared dictionaries. There's static resources that don't change a whole lot and can be pre-compressed. And for that model, we're looking at using one version of a resource as the dictionary for the next version of the resource when you do an upgrade. And then there's dynamic resources, which you use a side built custom dictionary, kind of like SDCH, for dynamic resources. But they both have effectively the same serving model. And it's very much first, the browser, whatever it is, fetches a resource. In this case, it's the YouTube JavaScript player, which is 10 megabytes of JavaScript, shipped multiple times per week as it gets upgraded. And Broti compression gets it down to around 1.8 megs. The response for the resource that you want to use as a dictionary for some point in the future carries a use as dictionary header that specifies the path, some level of wildcard support to allow version numbers in the URL path, for example, for builds of a JS resource. And in this case, the player JS has a wildcard after it, so the version number hash is immaterial, and this player JS can be used as a dictionary for any future fetches for any player JS files on the same origin. Some point later, user comes back, the player has been updated. Browser does a fetch for player.js version 2, and it says, hey, and by the way, I have this dictionary, and it sends the SHA-256 hash of the previous version of the player that it already has in its cache. The server recognizes the previous version, has a delta compressed version of the new player that is much, much smaller than the Broti compressed. It's only 180K. And it sends down the delta compressed version that the browser can then use the old version in cache as a dictionary to decompress the new version. And effectively, what this gives you is delta compression, where the server only sends down the bits of the player that changed versus what the browser has in its cache. It's a little more overhead than just pure delta compression, but it effectively comes out that. And so the size of the delivery is effectively how much changed since the user last visited. It's worth noting that as far as the browser and everything else is concerned above the networking stack, it's still a 10 megabyte JavaScript file that you're parsing and running. So it doesn't make the player any lighter, but it does significantly reduce the delivery size. In the dynamic case, it looks very similar, though the one difference is, and here we have a search use case, but it's any HTML page or any resource for that matter that's not doing version to version upgrades. A fresh user comes, visits the page, gets the HTML like it normally would. In that HTML or in a response header, there's a link tag that says rel equals dictionary and points to a dictionary URL to use. And it's basically a way of side loading a dictionary instead of having one as a static resource. At some point in the future, the browser, when it's idle, downloads that dictionary, and that dictionary will have the same response that the static resource has, the use as dictionary, and it has a path of same origin requests that this dictionary is appropriate to be used for. So in this case, the dictionary response says, hey, I apply to any search query pages. And so we can have a custom dictionary that was built for the search page templates, or you can have a mobile and a desktop. If you're an e-commerce site, you have landing pages, product listing pages, search results page templates all have separate dictionaries, for example, that can apply and have effectively the custom boilerplate headers, SEO tags, footers, kind of stuff in the custom dictionary. Then at some future point, the browser makes a request for a URL that matches the path of a dictionary that it has. In this case, it's the search path that has the dict.dat dictionary as a side channel dictionary for it. And it advertises, hey, available dictionary, the hash of the dictionary, and the server can delta compress the dynamic HTML at serve time with the static dictionary that was downloaded out of channel. So the actual dictionary matching rules, serving rules, compression logic, all of that is the same. The main difference between dynamic and static is the dynamic use case really just has a way to out-of-band fetch a dictionary. In theory, if dictionary.dat was a resource that was on the page, it could have also said link rel equals dictionary and been used for other search results pages. It's important when you generate these dictionaries that they not include private data. And I think I've got it on a slide, but I'll talk about the privacy protections in a minute. As far as the results that we've been seeing, this is all mostly lab testing. And there is, in the examples page in the explainer, there's also a link to a tool if you want to test against arbitrary static or dynamic pages of your own to see sort of what kind of benefits you get. On top of Broti compression, we're seeing anywhere from 50 to 90, even 99% savings, depending on how big the deltas are, additional compression savings over Broti. And so it's one of those orders of magnitude smaller even than the best compression that we get today, both for dynamic and static bundles. And oh, there's the mouse. There's a bunch of reasons why this works better than previous attempts. Probably the main one is that it's no longer hidden at the transport level and done automatically. It's collaboration and working with the pages and the serving architecture of the web. It's effectively cache-enhanced compression. So things that you have in your cache partitioned as your cache is normally partitioned with all the security protections and everything else can be used as effective delta compression for future fetches. We're not targeting to do anything about the first load. This is all about future engagements. So version upgrades of scripts or bundles, WASM, huge WASM app updates, or multi-page visits when you're browsing an e-commerce site where you can amortize the dictionary cost over a bunch of different page loads. The dictionaries themselves are managed similar to cached resources and cookies because they can be abused as identifiers. And so they're stored, they expire, they're cleared whenever caches or cookies are cleared. Because of the side channel attacks, the dictionaries can only be used for CORS readable responses. So the dictionaries themselves need to be CORS readable by the page, and the resources they compress need to be CORS readable by the page. It's a little bit of a dance around the privacy problem. It's basically saying, yes, you can attack with timing attacks if you wanted to and get to the contents of this. And so we're going to scope it to only be applied to things that you could normally read anyway, and just wipe away the privacy concerns. For the most part, that solves just about every use case that we can think of, and should be the 90% case. And it's content independent. In theory, you can use it against binary content, but even just using it against JavaScript, CSS, WASM, JSON, SVGs, HTML, sort of all of the big heavy text resources that tend to have a lot of common template content or repeat content, we expect to see a lot of the gains. As far as deployment, the static build version, the static file version, I think is probably going to be the easiest path for initial ramp up, because you can do it as a build step, as part of your build. As a post build step, you store the artifacts of the build, the JS, the CSS, whatever, into a version store you've got somewhere that has all of, or some rolling number of previous builds. And then after the build is done, you compress each one of the current artifacts against the previous versions of that file, to have pre-compiled dictionary versions of the assets. And then at serve time, you basically just say, hey, use these resources as a dictionary for future versions of this resource on the same path. And when a request comes in that has a sec available dictionary request header, you can literally just look on disk and see if you have an artifact on disk already that was delta compressed with that available dictionary. If not, you just respond with the normal Brotli encoded full resource as you would normally. But if you do, then it's just literally a pick a file operation and send down the tiny version of the delta compressed file. The dynamic case is a little more complicated because you actually have to have the server or the CDN actively applying the compression with the external dictionary at serve time. Still hugely valuable, and I do expect we're going to see a lot of uptake, especially where there's a lot of value in that use case. But the static case is kind of a no-brainer for almost anyone to add to their build process. As far as CDN requirements, they're sort of the CDNs can actively participate, but it's also, there's a risk of CDNs breaking support for it, just by virtue of how they normally work. And the biggest risk for that is the content encoding. They tend to like to be the place that the content encoding is done, Brotli or gzip or whatever, and they operate on a lot of the content that flows through. For this to work, they need to either recognize shared Brotli content, or they need to at least pass the accept encoding SBR and the content encoding SBR responses through, and cache resources separately using the vary for sec available dictionary, so that delta compressed versions of each resource are stored separately in the cache and responded to appropriately. So this is kind of the baseline minimum. If you want to get this working with a CDN and not have it break, they need to at least be configured to pass these things through. And there are, future opportunities for CDNs to be much more involved in the process. Instead of you doing, or the site owner doing the builds statically at build time, in theory, you could just add the relative, or the appropriate uses dictionary headers to the resources on the server side. And then the middle boxes can observe those uses dictionaries, store those as SHA hashes in a key value store. When the browser requests a resource and says sec available dictionary, the middle box could do a batch process async offline to recompress those resources with the versions in key value store, and make it available for future requests. And so it fits fairly well with the offline compression model of CDNs today, just with a little extra step of watching the headers as they flow back and forth and managing dictionaries in a key value store. And, there's sort of future ideas where, CDNs being more active could also provide a UI mechanism or some mechanism for you to provide regexes of paths for my app resources, and they do all the header management themselves as well. And they could handle the dynamic dictionary use case as well. There's a lot of flexibility built into the current proposal. The actual compression, the shared Broti, which is the use case we expect to go out the door first, is completely independent of the negotiation of the dictionaries. And so the use as header available dictionary can happen independent of accept encoding and content encoding. And so if there's a new super duper WASM aware, offsets aware compression mechanism or Z standard or something like that, you can keep the existing dictionary mechanism and just add it to the content negotiation. There's opportunities on the build side to provide or to produce built assets that are more consistent from build to build, being aware of delta compression. And so static variable maps and function name maps and things like that to reduce the size of the delta compressed assets. And there's all sorts of research opportunities for generic out-of-band dictionary creation. The Broti project itself has a dictionary generator where you can give it a whole bunch of files, resources, and have it generate dictionaries using different algorithms. But that feels like an area that what's the optimal dictionary to generate off of these resources is probably still ripe for a lot of research and work. There's a lot of stuff. This is still very early. We're planning to prototype it in Chrome and start experimenting with it. We do have a YCG explainer that we're starting the discussions and bike shedding on everything, but there's a bunch of stuff going on. We have to be careful to minimize the cardinality of the vary response. So since we're going to vary on accept encoding and the available dictionaries, we need to make sure that we don't end up with clients with thousands of different available dictionaries. If you have like the dictionary set to go for a year and you're doing multiple releases per day, you could get clients coming back all sorts of times and have your middle box caches just sort of explode. And so when you're setting the expirations for dictionaries, you want to keep that in mind and go, okay, what's a reasonable time window to do delta compression against? All sorts of bike shedding on the naming. We came up with headers that we think make sense and values and compression tags and dictionaries, but everyone's got opinions on names, so those may change. Those are what we're using as placeholders for now, but who knows? The path matching. Right now, we started out with just doing a prefix match. We learned pretty quickly that won't work. Lots of people have build numbers as a directory effectively in the path for the static resources, and so you need to have at least path matching that allows some sort of wildcard in the middle of the string. For now, we're using the same wildcard support that the extensions manifest V2 and V3 support for URL matching, which is basically, you can put wildcards, stars in the URLs, and that'll just expand. But is there a need for something more complex than that or not? Don't know. The hash algorithm and how it's represented. SHA-256 is what we're using right now. It should be perfectly good for unique file matching, especially within an origin. The protocol does allow for future expansions of what algorithms to use, but should that hash be encoded as base 64 in the request headers to keep it smaller, or base 16 in the request headers, which is slightly larger, but it's all ASCII that can be encoded in a file path, whereas base 64 includes slashes as available characters. And so with base 16, a lot of command line tools output base 16. And so you could literally just take the header value and look for that value as a file extension on disk and do a quick mapping. And so we're leaning towards base 16, even though it's slightly longer, just for ease of deployment. Broti support. So the shared dictionary support was added based on all of the attempts that we've been trying to do. So big thanks to the Broti team for this, but it was added in August 2021. The last stable official release of Broti was in August of 2020. So if you do apt or brew install of Broti today, you don't get the version that has the -D command line option for external dictionary support. You have to build it from source. There will be a new release of the Broti code in the next month or two that includes all of the optimizations they've done to the code over the last few years as well. And so hopefully soon, the tooling is easier to install for experimenting and doing with this. As the code currently stands, external dictionaries are only used in the Broti compressor if you set quality level 5 or higher. It's arbitrary. There's no real restriction to it. And so we're going to work with the Broti team to see, hey, what does it look like when you use external dictionaries and Q1? Can you get the benefit of low CPU overhead? Because a lot of dynamic compression with Broti today on the edge is done at Broti level 1, mostly to be able to say, yes, we're doing Broti, get a lot of the bulk of the savings, but with minimal CPU overhead. And if we can cut it in half while using dictionaries and still not increase CPU significantly, that will probably be a net win. Standards path. This should be rather challenging. It's coming to Chrome in Origin trials soon. You will all be informed. Figuring out what are the rough edges, the deployment, how does it work in the wild, sort through any CDN issues and things like that. There's the IETF HTTP working group. We've already talked to them about getting started on it on this last Sunday at IETF in Japan. Feedback so far is very positive. I don't remember hearing any negative feedback, which is rare for this kind of thing. I expect the bulk of the standards work is going to be in the HTTP working group because that's where the bulk of the actual compression and negotiation happens. But there are pieces that touch fetch and HTML specs around the browser-specific cores and privacy requirements and the link tag for fetching external resources. We're optimistic that this is the time. This feels very much like it's shippable and deployable without a lot of work on developers' side and should solve the bulk of the use cases. So both Yoav and I are extremely excited about the possibilities that this can bring. And that was it.
Yeah,
I stop the recording.
That excitement, and I'm stopping the recording, and then we can discuss.